and it's good to be here again. I've prepared some gifts for some of you because I'm going to give a quiz at the end of my presentation. So I hope you can participate this way. Yeah. One is the high mountain tea from Taiwan. The other is pineapple cakes. So two questions I'm going to ask at the end of the presentation. So please pay attention. So basically, this is the outline of my session. I'll talk briefly about our organization, III, and also what we're doing in Kuwait. We have established an office in Kuwait. It's called Kilo. And at the end, I'm going to talk about this energy management platform in Synergy. So we are established in 1979 as a quasi-government organization. It's actually a joint effort between the government and the industry. And our mission, most importantly, is to facilitate the development of Taiwan's ICT industry and promote the deployment of ICT in public and private sectors. So, as you can see, we are specialized in ICT. But how come we're doing this energy and other technologies? I'm going to explain later. So we are already in existence of 36 years, and we are the largest fully functional ICT research institute in Taiwan. And this is our organization chart. Basically, our main focus is research and development. We have 2/3 of our staff are in these institutes, ranging from the network for the innovative applications, data analytics, and cyber trust, information security, even the IT education, digital education, and market intelligence, and science and technology law. And I'm from this the service divisions, international division. And there are also other divisions facing towards the domestic businesses. I'm from the international division, so this is what we do. We try to reach out and try to promote Taiwan's ICT capabilities. And we have 2/3 of our staff is master and above, basically, and we have 2,000 people. So basically, we're very heavily involved in ICT-related value chain, basically. And we starting from the research and development. As I told you, our main focus is research and development. And we even have incubation centers. We have 3 incubation centers in Taiwan, 2 in the north and 1 in the south. And we also have, we organize this innovative entrepreneurship competitions. We call it idea shows every year. And it's one of the largest entrepreneurship competition of its kind in the Asia region. And we also are involved heavily in the industry development. And we have a lot of awards or recognitions from around the world. So we create value in the innovative ecosystem. And this is our business focus. As research and development is our foundation, then we gradually provide other functions, such as think tank and professional cultivation. Think tank as in we provide a consultancy or the advice for the government. And professional cultivation is we try to educate people with IT skills. We try to give them a second skills for them to maybe to apply in their job or to find new jobs. There are a lot of students who are non-IT background, and we provide training for them and grant them the certificates. With these certificates, it's widely recognized in Taiwan. They can find jobs that are IT related. And industry promotion, with the shows, with the exhibition we organize, we try to promote the industry. And we also promote the application. I'll give you some examples. Energy management is also one of the applications we try to promote in Taiwan. We have this whole neighborhood. We call smart living neighborhood, and we try to use this neighborhood as a POC site for a lot of the ICT-enabled applications. Energy management is one, and in the interactive learning in the schools, that's also another example. And with all these capabilities, we're looking into international cooperation. That's why we are here. We're here in Kuwait, and we're trying to see what we can bring to other GCC countries. So we are as a bridge between, this is in Taiwan, we are as a bridge between government and industry to facilitate ICT-enabled innovation ecosystem in Taiwan. But now we're changing our focus to international cooperation. That's why we want to basically bring our model to abroad. And Kuwait is one of the, Middle East is one of the main focus for us. And this is our research and development framework. Basically, at the bottom layer, you will see some of the core technologies. And we're all involved in three layers of this research and development. Basically, we started from cloud computing and communications, embedded systems, cloud systems, and these are all core technologies. And we try to put another layer on top. For example, the user experience interaction and services, and we can develop different applications. Smart application, smart green, for example, energy management is one of the examples under smart green, and smart living, smart media, etc. So we have, as I mentioned, we are a research and development focused institute. We have a lot of patents that are developed, and we develop these patents to transfer to the industry. So other than the annual growth you see from our patents record, but also you can see the technology that we have transferred, because we transfer these technologies to the companies for a small fee, but not as a, because government put most of the investment in these technologies, but we will try to transfer them to the companies, so companies can use these technologies to develop their own products or solutions. We try to promote ICT usage in Taiwan this way. So other than the patents, and also we have a gradual increase in the revenues. So just some of the track records you see here, and some of the big names. I think you all know Acer's from Taiwan, yes? And all these big companies have transferred technology from us to make it their own products and solutions. And international awards over the years. In Synergy, which I'm going to talk about later, the energy management platform, also was awarded this is the American competition, Research and Development 100. And this is, I think we still have two awards in 2014, but it's not listed here. And this is what we have done over the year as a government think tank. In the beginning, we tried to help the government to facilitate the national infrastructure. with the planning, and gradually, as it is required, there e-Taiwan national initiative, electronic Taiwan, and mobile Taiwan, and now we have moved to intelligent Taiwan, and all of these policies or initiatives were initiated by III. We are behind the national policies, basically, and national initiatives. And this is the industry promotion, like we said. Other than the technology transfer I mentioned, we have also tried to facilitate the business incubation and policy tools. We provide the incentives like subsidies for the companies to apply maybe some certain government programs. For example, I'll give you one example. For example, if the company is trying to develop this innovative service or product, and they can apply through us for government grant, but they have to invest the same amount. For example, 1-to-1, 1 million US dollars has to be matched by a company investment of 1 million. And this is how the government is trying to develop the ICT industry, because in this way, also we as an organization, we can evaluate some of the applications from the companies, whether this is indeed innovative or it's really worth investing. And we are the one that's also guiding the company and also helping to facilitate these grants. So throughout this policy tools and incentives, and these are some of the major milestones that we have achieved for the Taiwan ICT industry. Cloud computing is the most recent one. And again, these are the awards we have received. This is the professional cultivation. We try to educate the college graduate with the second skill. And we also, we are the main agency that's providing the ICT training for the government institutes. So yeah, they're not people from the embassy here, but they all know when they're throughout their career, they have to come to us for additional training for the credits, for their advancement in their career. And we also, and gradually we started from the job training, job IT training, then we can provide the professional training as well. We cooperated with international companies for their certifications, Microsoft and Cisco certifications. And now we are trying to move to the e-learning approach for this IT education. Over these 30-something years, we have trained close to 430,000 people. So if you ask anyone from Taiwan, they will know us and what we do. And more or less, maybe someone, he or she, has received training from us. This is, again, another example of how we try to promote the applications. Started with 30-something years ago, the PC penetration rate is less than 1%. And we tried to organize these exhibitions and shows and basically bring the awareness to the people that there are things such as computers. And as you can see, and combined with the national initiatives that we provide the government, the infrastructure related and the e-readiness related, like the electronic Taiwan, mobile Taiwan, intelligent Taiwan, we have raised the penetration rate to 98%. It seems normal that everyone is using the computer and the internet, but it really needs some efforts from the government to achieve this penetration rate. And Taiwan is famous for ICT. It's not famous for no reason, because there's things that we do behind that we try to promote. And that's why you see products like HTC, Acer, Asus, they're all from Taiwan. And this is just the, we have a variety of partners in this ICT field. And basically, we have cooperation with the, this is just some of the examples, some universities from the States, and also a research institute from Japan, and most importantly, KISR. This is the agency that we work with in Kuwait, Kuwait Institute for Scientific Research. And we have business partners. They either cooperate with us with the technologies to be applied in their products, or we help them provide the certifications like Microsoft and Cisco. And venture capital partner. We also, because like I mentioned, the entrepreneurship ideas show, we cannot just have the competition with the new startups, but we also help bring in the venture capital companies to try to invest all these companies and try to grow as a company. This is, over the years, our international operations. And other than, I'm going to talk about the Middle East, because I'm the one who's mostly involved in all these projects. We have before have a government training and workshop in Bahrain, and healthcare training in Saudi Arabia. And most of the projects are in Kuwait. Not only we have the IT projects, but we also help provide consultancy service to the government for their science park and etc. In Oman, we have one project before with the Visual Innovation Center. I'm not sure if you're familiar with this, because this one is before my time, so I wasn't too sure. This was 2-3 years ago. And now we're trying to see any more opportunities here that we can help bring to Oman. And other African countries, these are the countries with the official diplomatic relationship with Taiwan. I don't know if you're familiar with Taiwan's situation, because we have China on the one side and we have Taiwan. And China is the member of the UN, but we're not. But we are a country. We still have our own passports. We still have our own governments. But we're not recognized internationally, especially in the UN forum. And these countries, they recognize us. And we provide a lot of aids and cooperation with these African countries. These countries, also basically other projects you will see, these two are also our diplomatic relationship, official diplomatic relationship countries. So basically, our future outlook will include continuing the research and development in the new applications and new fields. And other than promote innovation and entrepreneurship, most importantly, we want to expand internationally. And I'm going to talk about our operation in Kuwait. We have 5 years of science and technology exchanges. So it dates back to 2009 when we first started the cooperation with Kuwait. And just recently, in November 2014, we established this office. We call it Kilo, Keyser III Liaison Office. And I'm the one who's now stationed in Kuwait. And we try to go beyond research and form a strategic partnership to deepen the commercialization and industry development for Kuwait. So basically, we started off, this slide I'll explain more. We started from IT to more. In 2009, we provide Keyser IT projects. They're internal systems, like project management systems, human resources management systems, and we even have a consultant team now based project-based team in Kuwait. And they started to get familiar with the Taiwan way of things. And they kind of like, because before they emphasized cooperation with the West, like US, like Europe. And through these IT projects, they get to know us more. And they ask us whether we can introduce any other Taiwan technologies to them. Because as you know, Keyser is focused on a lot of research activities, not only in IT. They have water-related, also petroleum and agriculture and aquaculture. These are the main research areas of Keyser. And they ask us whether we can facilitate other technology cooperation. And we agreed. And from 2010, we have annual workshop. We call the workshop Keyser and Taiwan Institute's joint workshop. And just past June, we have our 5th workshop in Taiwan. Basically, 1 year in Kuwait and 1 year in Taiwan. And we try to bring together Keyser scientists to Taiwan research institutes or universities or industry partners. So these are some of the examples that we have introduced to Kuwait. It's the National Applied Research and Laboratories. And under this agency, they have the National Space Organization. And these are all Taiwan institutes I'm talking about, and Taiwan Ocean Research Institute, to help them to do some research or cooperation in the respective areas. And also the National University, National Taiwan University. That's why I'm glad we have this chance today, being invited by our Royal Daily to bring experts from the National Donghua University to share with you the solar technologies and things from Taiwan. So basically, the office that we have established inside Keyser. So this is what I mentioned, the 5th Keyser Taiwan Institute joint workshop. It was held in Taiwan. And I'm just going to go through briefly so you'll know how deeply that we are involved with Kuwait and what are some of the things that we're doing with them. So basically, it was a week program, and our main focus is to exchange the latest technologies in the advanced technology applications, and to share our experiences, and we have a discussion for future collaboration. And basically, these are the organizers and co-organizers from Taiwan. So we have developed all the delegations into 5 tracks. Basically, for each track, I'm going to talk about the tracks. We have healthcare IT system technologies and advanced process control. This is applied for the petroleum industry. And the aquaculture technologies and energy efficient. This year, we have the energy efficient systems and technologies included as one of our tracks. Basically, for each track, Keisha has assigned 1 or 2 scientists to come to Taiwan. And what we do with them is the first day we'll have a big workshop where all the scientists from Kuwait and from Taiwan to present briefly their research findings in just maybe one person is given 30 minutes to share on their research activities. We try to have a forum so that they can not only share among each other, but also we invite all the public audience as well. Not only the students, but also the industry representatives. They are present at this forum to see, okay, this is Taiwan can do, this is what Kuwait is doing, and there must be something. And it's also good to know for the students, for the general public. And then we divide each track into separate programs. Basically, we will arrange some specialized site visits for each track. So basically, the healthcare people, the scientists, they will go to some of our hospitals and the Ministry of Health to see exactly what our government is doing in this regard and what the industry-wise, the solutions there to support the government in these respective areas. So it's a long, actually for them it's long because I think they're not used to have meetings from morning to afternoon. But this is the way of things in Taiwan, in Asia in general, that we like to have a lot of meetings. And basically, after the first workshop, we have the site visits, and then at the end, we'll have a wrap-up, just to wrap it up with all the tracks. So like I said, there's a joint and group discussion and site visits and wrap-up. These are the people came from Kuwait. And these are the list of agencies that are involved from Taiwan side. Basically, you can see we have 8 government agencies and also 10 research institutes from Taiwan, even 24 industry representatives that are participated this event. Just a list of government institutes that were part of this workshop. Ministry of Health and Ministry of Economic Affairs. This is our Bureau of Energy is under Ministry of Economic Affairs. And also they're very eager to develop their own small to medium enterprise. So we have the Small to Medium Enterprise Administration, and we have Ministry of Science and Technology. All this government institutes, fisheries agencies, and these are the research institutes. III is one of them, and other Petroleum Institute, Electronics Tasting. This is related to the energy efficiency track, because Kuwait, they would like to build their own labs in appliance testing and appliance research. That's what they're looking for, and we have I found the related agencies for these areas. Also, they are looking for the building energy research, and it's not listed here, but there's also another building related research institute. Maybe it's here. No. Okay. Anyway, and some of the industry partners. This is just from the meetings that we have arranged. Some pictures of their visits. This is the fishery group. These are the fishermen with PhD degrees. And this is the breakdown that of our event. In total, we have 81 people who have attended, and ranging from the research institutes, government, and industry. And because of this collaboration, there are 5 MOU agreements will be signed. And once that's related to the energy, is signed already, because they are really eager in this regard. Keyser and Electronics Testing Center MOU has already been signed, and the rest are still in process. This is the picture from the opening of our workshop. And this is the president of III giving the opening speech and the keynote speech. This is the lead delegates from Keyser, Dr. Nader Awadi. And the glance of the workshop audience. And like I mentioned, we have for each track, we have a representative to talk about the related topics. So it's very interesting, even for us to know more about what's going on in this respective research, and what's the trend, and what's the future. So we have someone talking about the health, because Taiwan is really developed in health services, not only for the medical services itself, but we have a strong IT system that's behind all these medical services. Basically, you have we have each person, we have a national health insurance card, and to each hospital or even private clinics, you can just use this health insurance card they have their medical records, and also they can claim the reimbursement from the government, because you have go to their clinics with the national card. And also some of the, this is ICT data analytics session. And this is for the petroleum, for the aquaculture, and this is for the energy. Basically, I'm going to talk about this later. And this is from the Keyser side to talk about Keyser's prospect of the energy efficiency plan. Basically, solar is also one of their focus now, basically, other than the testing and research labs they want to build, but also they want to adopt some technologies that help them not only to generate energy, but also to manage the energy efficiently. Oh, this is just a recent activity that's related to Oman. We have Oman Public Establishment for Industrial Estates visiting us in Taiwan. And basically, these are the officials. And we try to talk to them about the Oman IT vocational training, and also Oman ITS, e-government development. And that concludes my introduction of our agency and the office. And I'm going to talk about the energy efficiency platform. So this is the energy management platform. We call it in Synergy. It's developed by one of our research institutes, and it's also cloud-based. This is the outline. Basically, we're facing, I think you're all familiar with this. we're facing a problem in the cost of electricity. Basically, we have some cheap ways of generating energy. For example, the coal and nuclear. Nuclear is relatively cheap. And there are more expensive ways, but more environmental friendly ways of generating energies, such as wind power, solar power, biofuels even. And all in all, we're facing a cost of power, energy, and generation have increased gradually over the years. And the consumption as well. We have a very steep increase in the consumption. Basically, that's also what contributes to the increasing cost of energy. And what, as a IT research and development agency, we're not familiar with the power generation. These are up to the University of Donghua to tell you. It's solar is something that they will share, and other ways of power generation. We're proposing, by saving energy, you're generating another source of energy. So fifth source of energy, we call it energy efficiency. Then we're going to introduce some of the ways that we try to help save the energy with IT technologies. So this InSynergy platform, we have 4 application areas. Basically, one for the household use, energy usage. And the second for the industrial energy usage. And third, for the street lighting management. And last, but not the least, solar management. These 4 are the application areas that can be applied with the InSynergy platform. I'm going to talk about the household management first. Basically, this is just an overview. You can see with the router and the specialized sockets that we have developed, we can link with the various devices that are applied in the household. For example, the lighting, the camera even, detector, smoke detector, CO2 detector. All this can be linked and even interact through our system for the remote access, scheduling, and abnormal detection. Then you can be notified this problem, like any abnormal activity right away, then you can take measures. In the end, because of this, we want to reduce the energy bill and increase your comfort and safety. So this is basically the flow of informations in this system. We have all the information from the appliances gathered with our gateway, and basically it will be uploaded to our cloud system, where some of our softwares can help analyze these collected data, and at the end output to this interface for the end users to monitor and control, basically. These are some of the components in this household energy management system. This is the router. This is the gateway that's collecting all the wireless signals from all these sockets. So basically, you plug your appliance or device onto these sockets, and they'll send the signals to the gateway. So basically, before, you only know your energy consumption maybe at the end of the month when you get the energy bill. You only are notified maybe there's a sharp increase in your bill at the end of the month, which means You don't know exactly what's consuming your power, and it's too late to do anything about it. And with this, you know any activities real time through the internet. Basically, this is stated, you only know what happened at the end of the month, but with these systems, you understand the energy usage in real time, and you can adjust in real time. So you are basically effectively track the power usage of your home appliances in real time. And you can use it with PC or with mobile phone. This is, I think, the interface with the PC. You see some of some of this is in Chinese, but for the PC usage, for the fan usage, you will know the real-time energy consumption, and you can even turn off the appliance remotely. This is what we have designed to turn off the appliance. Just one click away to turn it off. And this is the interface for the mobile phone. Because our software helps you to identify some abnormal activities. And you see this, the color indicates the overusage. I can't tell what these are. But it looks like the water, the thing you can heat the water. Anyway, it's a one click away to turn it off. And real-time information. If you have kids at home, and you're maybe you see, someone is watching TV at your home, and they're not supposed to. The kids are supposed to doing their homework, but they're watching TV, because you can tell from the consumption the appliances are on. You can turn it off. I don't know if the kids are smart enough, to unplug the socket. Bypass, yes, bypass. Then it doesn't work. But anyway, it's one of the things you can do with the system. And we can also apply this in the industrial application. Other than like the personal or the equipment monitoring, like the home household, we can also collect the information from the circuit, basically from the lighting also, for the outlet also. We have a different gateway to collect the information. At the end, we just try to consolidate the information that we have collected to analyze and feed back to the user with the useful, meaningful information for the user. And this is just an example of, because we have installed this system in our headquarters building. This is the layout of our headquarters. Basically, for the electricity information, because we connect this to the circuit, so we only know the usage of this floor in total. So this is the electricity information from this floor. Also for the lighting, because we connect to the circuit, we know the lighting power consumption of the floor. But with the AC, we have connect to the separate sockets, so we know the individual usage, and we even can control the air conditioning. Again, the same technology and concepts can be applied to this lighting, like street lights, for example. We all have the controller installed at each of the street lamp, and we all use the wireless technology to try to transfer the information to the back end, and we try to output this interface and meaningful data and control and management functions for the users. And this is a case that we have deployed in the Science Park of Taiwan. Basically, not only the lightings we want to control. All these green dots are the street lights. And also we'll try to control the CCTV, the camera, the surveillance camera data. And we combine this with the GIS technologies. So you see, this is small, but you can pinpoint each street light to see their power usage, and you even control and synchronize the lighting as well. You can dim the light or strengthen the light altogether based on the environment. Maybe it's a cloudy day. You turn on the lights and increase the lighting, luminous, all at the same time, or even just by section, because this is controlled by the circuits. So basically one section you can control. And we also have a way to control individual lights, but it's more costly, and it depends on your application. So basically, for each light, we can control, and we know the information. Even on the map, we can pinpoint right away. And these are some of the like public applications can be used with this kind of technology. Not only not only the street lights, but also for the port, for the parking, for the monument, the museum, or like your grand mosque. This kind of buildings, you can have this kind of technologies to manage the light consumption, and maybe even have some varieties to the lighting, because you can synchronize and adjust the luminous, and all this can be done in real time. So basically, our system can only try to manage efficiently the energy, but we're not really generating the energy. But combining with the LED lamps, like LED light modules, study has shown we can save up to 70% energy. And this is what we apply with the solar system. Solar is a good technology that can generate the power, because the sunlight is coming every day. It's very steady source of energy. You can expect the generation pretty much. You know how much you would generate. Especially like in the Middle East, there's a lot of sunlight, and usually if other than a sandstorm or not even raining days, especially in Kuwait, there's just five or 6 days that's raining in Kuwait. I'm not too sure about this. Maybe you will have more rain here, right? 1 day per month? No. Anyway, there are some reasons that can affect the energy generation of solar panels. Covered by dust. This is a common issue here, and from the quality of implementation, and just from the natural decline and the deterioration, it can affect power efficiency, power generation efficiency. So throughout the time, you will see this is the power generation output. I think throughout the time, it's not just by 1 day. Because of all these factors, the panels maybe they're generating less and less power, but you're not you're not that aware that what's exactly the root cause of this bad performance, basically. And what we have is an IT solution that can provide a 24-hour monitoring. And basically, it's like a care services. And we also This is the system framework. We're still monitoring the panels by string, not by individual panel. Because by string, I think it's more cost effective. We don't need exactly the information from each panel. We only know if there's a decrease or any abnormal activity from the string, then we can just go to the string of panels and find out what's the problem. And these are some of the components from this solar generation efficiency monitoring system. We have done this a lot in the African countries because they are really in shortage of energy. And we have helped deploy these systems, along with the solar panels, of course, to a lot of schools, universities, and it works. And this is real-time data for the production, for the consumption, we also have other sensors that can collect the irradiation and temperature, and our software will provide the performance ratio statistics. All this may be in this kind of display for you to see any abnormal or infunctional status. And this is just one of the reports or chart that can be generated with our system. You see the blue line is the power generation statistics. Irradiance is the red line. And the surface temperature is the green line. And the back temperature is the other one. As you can see, it looks like this is all in the normal way of things. So looks like this is no problem from this chart. And this is another display of the system that tells you which part of the system maybe it's not functioning well. You can monitor the status of each device. So basically, our systems help you to manage the usage of energy or generation. For solar, it's generation. For the usage, like the household, the industrial, and the lighting, it's the usage. And we have, like I said, we have this community that we call the smart living community, that we try to deploy some of our research and technologies to these neighborhoods and to see the effects. And we have some findings. Basically, like I said, for the house, for the commercial parking lights, for the enterprises, the industrial usage, we all have the reference cases in Taiwan. And this is from the neighborhood that I talk about. Over 3,400 homes that use the iFamily, for household usage. And for the industrial, this is the 11th floor of our headquarters. And because of these systems, and we are more aware of the energy consumption, and as a result, we have saved 10% of the energy usage. And this is the case in South Africa. This is a university. And we have helped install the panels and this management system in 2012. And these are some of the reports from the university. basically we're bringing awareness to the energy generation or the consumption, so you can do something about it real time. This is just some of the stats from the energy generation loss. If you are not monitoring your solar generation, basically if it is 30% loss due to the abnormal activities, and throughout the day, throughout the month, and to the year, you're facing 1,300 kilowatts of loss. So if you neglect this solar power generation performance, you're basically wasting your money on your investment. You're not aware that it's not bringing you the money. I mean the energy or the money that you intended for. Because some abnormal activities include the solar panel defect, shade, efficiency drops, malfunctions, and faulty construction. Simply faulty construction. That can be a cause of your less performance. And this is one of our current research applications. We try to bring like a total comprehensive energy efficiency measures for the building. Maybe control the fans, the window shades, and parking lots lights at the parking lot, and also even the smart meter. We are also doing some research on. All the energy related or generation devices can be linked with ICT technologies, and this is one example. Our references, I'm going to go through this really quickly. We are awarded with the 2011 Research and Development Award. And these are some of the, do you know about 7-Eleven?
Yes.
Yeah. You have it here? No? No? Yeah, this is one of our big sites for our systems. And these are all the companies or the university even that use the industrial use energy management system. This is all company examples, enterprise company examples. 7-Eleven, retail stores, university, hospitals. And for the Africa solar reference case, Burkina Faso, also Burkina Faso, South Africa, university, schools, Zambia, Nigeria. Thank you. So now it's a quiz time.
Yeah.
I hope you have taken notes. The question's going to be easy. First question. What's the name of my organization and the office that we have established in Kuwait? Does someone know? No, please raise your hand. Yes, please. Kilo. That's the name of in Kuwait. And how about our organization? The name of our organization? Oh, someone is helping you in this? You have to share then. Or you, please. Okay. So who should I give it to? Well, it's a. I think I'll give this one because there are more than one piece of cakes inside. This is the pineapple cakes. It's very famous in Taiwan. So maybe you can share. And you can share with your classmates as well. Last question. The energy management platform in Synergy, there are 4 application areas that we have. Can someone name the 4 application areas? No, you have to raise your hands. Yes, please.
iFamily.
For the household, yes.
Externally.
Xuri, yes. For the industrial use. For the light, yes. For the solar, yes, exactly. Thank you. This is the T.
Thank you.
You can make tea and drink with your friends. Okay, that concludes my presentation for today. I hope you like what I've presented. Thank you.
Okay, we'll take a 15-minute break. Okay.
Yes.
Can I take a second presentation?
Sure. Can I have your email, or it's better if you have a USB because I don't have internet here. I can just copy to you right away. Or you have an email?
Thank you.
Thank you. Yeah, okay.
Second presentation.
Yes.
Sir, can I have please your business card?
Yes.
It's available.
Yes. Thank you. Yes. If you are interested in the, thank you very much. These are some of the solar technologies, because I was told that I shouldn't be too commercial, but actually we're working with these companies for solar applications in Kuwait. They're helping Keyser with their, maybe just some information for your reference, because they're looking at.
Okay, we'll start this lecture. As I promised you, we will discuss about our lab result. So we'll start from the first phase experiment. What is the lab work that we did for the first phase? IV curve, right? Yeah. So we take the first group, take IV measurement under, and while putting the panel directly under the sun, right? So the temperature rises to 55 degrees Celsius. This is not what I was planned before. I thought when we put this panel, then the temperature will be around 25 degrees and gradually increases. So in the meantime, I can measure the IV curve for different temperatures. Somehow it increases to 55 immediately. Okay, so this is high temperature. And later on, it causes malfunction of our controlling IC. So we cannot work that anymore. So we move, instead of move the module, instead of under directly sunlight, we move in the shade. Actually, in the shade, there's still sunlight. It's just not directly illuminated. It's like indirectly illuminated. Still strong enough. So take a look. It's a very good 55 degree. Very good curve. The voltage at 18 and the current is 0.7 amps. Very high, right? Okay. So thank you for the first group doing this. I forget which one is first group. Okay. Yeah, that's your work. Now, we are going to the second group. Second group is when we find some problem, we move the panel in the shades, under the shades. So, you see, the voltage drops. Not dropping significantly, but drop from 18 volt to 16 volt because that curve is going downward. You see, now the current is not 0.7, it's 0.08, 10 times lower, 10 times lower than the previous one. All right? So this is very good, even though the temperature is still around 50 something. But since you move in under the shade, so the curve reduces significantly. And since we already discussed about the IV curve for the solar cells, right? So you know it's moving up and down the offset because of the strength of irradiation. So you'll be able to get this. And since the current reduces, so voltage also reduces accordingly. But the reduction of the voltage is not as significant as the current. All right? Okay, so thank group 2. Okay. Now, this is a little bit strange. I don't know why. Now temperature dropped to, we just wait probably 10 minutes after. So when the third group comes, the temperature is lower, right? The temperature is lower. And I was expecting it should be have a very good measurement result, but somehow.
But it's still good.
Well, hey, you see, temperature current increases a little bit, right? But why the voltage decreases? You know what? Because I happen to notice when you are working, when group 3 is working, it is partially being illuminated directly by the sun. So it has shading effect. I see. That's why you got very strange things going on. You have a higher current, but you have reduced the voltage because some are shading. Say the power output is not matched for all the cells that's connected in series. So that's why the experiment, when you conduct experiment, you should be very careful. You need to illuminate all the cell consists of the module to be the same. It will generate high power. Otherwise, there will be strange thing going on. Actually, it's not strange. It can be explained, but just not as not typical IV curve. All right. So this can teach us something. Still, when it's shading, even though we are not purposely doing the shading experiment, but this one will show us when you are not illuminated the module evenly, you will sacrifice some current voltages, some. But why the current increases compared with previous one? Because you are illuminating portions of that, so they give you a little bit increase on the current. All right. So this one is not group 3's fault. Okay, member of group 3's fault. We still be able to learn from this result. All right. So thank you for group 3, member of group 3. Okay, now this is group 4. Group 4 temperature dropped to 37.2. Now back to, because now around the temperature that it will go down as low as possible at that day. So I believe they measure from high voltage back to low voltage. Is that correct? Anyone belong to group 4? Please raise your hand. Nobody wants to admit? Are you?
No, group 1.
No one. No one. Okay. I believe that you are measuring from the high end voltage back to the low end, right? Huh? Yes, our group. So we are expecting that the current will saturate instead of going down, right? But why it's going down? And especially there's 1 point here. I don't know why we have 0, 0.
Starting point, you know?
No, starting point is here. No way that we are going to have this point. Oh, maybe typo. Or I don't know. So this one is definitely not correct. But the problem is why it keep going down. I thought, did anyone can give you any possibility about the current drop down when you are measuring this curve at the end of the measurement? Why the current going down a little bit?
Maybe someone was near the babies.
I believe so, because someone already told me this. Someone told me on that day, because I also very curious about why this is going down. Somebody told me when they are doing the last few point measurements, someone just walked by and blocked the block the sun. Not even though it's partially because they are scattering. Light is scattering everywhere. So if we are walking behind the sun, you are blocking some scattered light. So it may affect you. All right. So that's why you know experiment need to be very serious about the experiment to control everything, other than the parameter you are going to vary. Otherwise, you'll get very strange results. Sorry? Yes, then I still cannot explain this 0. So make sure that you record your data correct, all right? Why you get 0? Huh? Loop, huh? Open loop. Sorry, probably you need to eliminate this point. I'm not sure. Okay. And also, yeah. So, and another problem is, another possibility I was thinking about is, will the temperature dropping along the time you are measuring? Yes. If so, then current at low temperature, the current will increasing, right? So I can eliminate this possibility. It will only increase, not decreasing. Okay, so that is probably someone is really standing by the panel that's causing this problem. Okay, anyway, we still thank Group 4 to give us. Okay, now Group 5. Now temperature, previous 37 point something, right? So it won't go down further, even though we are under the shade. Still, the temperature is pretty much stable at that temperature. Okay, so now this makes more sense. Now this is a more reasonable curvature. The voltage is around 18 because temperature already dropped down, and the current now is like something like point something. All right, so this is a very good result. That is under shade, not under the shade, like a less illuminative, but at low temperature. All right. So I was thinking about, yeah, even though we are not put the module direct under the sun, but we really still have the same illumination. Even the same illumination is under the shade, but same illumination, but different temperature. Do you remember? We are measuring this at 37 degrees, but in Group 2, we are measuring this, the same thing at 51.8. Also under the shade, same illumination condition, but different temperature, right? So in some way, we did successfully, even though not all groups are doing the same thing, but I can collect something that makes real reasonable comparison, all right? So I want to compare IV curve for 51 0.8 degree, and the one IV curve that is done under 37 degrees Celsius. So yes, you can put that. So that's why I'm drawing. This one. Okay, look more professional, right?
Yeah.
Look like your textbook, something shown in your textbook, right? Oh, this is what you have done by yourself, group 2 and group 5, I believe. And the rest of the group also contribute, even though your data is not shown there. See? At low temperatures, we have higher VOC, but a little bit lower JSC, but it's hard to tell. It's hard to tell. The difference will be different, small enough that we can hardly measure, because our uncertainties is like this, so you cannot see the difference. All right? And at high temperature, then we have lower VOC. So is this the same as that we already learned yesterday?
Yeah.
Yeah, very good. Thank you.
The blue one is the best because
The-
the area is more.
Blue one, yeah, blue one is better than the red one. Yes. So that's why we need low temperature. We want to keep the solar module as low temperature as possible. All right. So in the hot area, we might need to use water or something to cool down. But again, you need to consider the cost. All right. But if you are going to use water, hot water anyway, then you can do this. Just collecting thermal energy while you are reducing the thermal energy from the solar cell and to generate even higher solar energy power output. Okay, so this is the first experiment. Let's go to the second one. Second one. What is the work that we did on the second experiment? Huh? Shading effect, yes. Oh, I'm sorry. Okay, so take a look of this one. The blue line means not shaded, not partially shaded, and the red one is shaded, and this one is shaded. One of the fully one panel of one of the two panels, all right? So, and this is series connected. So you will see for series connection, you have two times of voltage, all right? But you have only 0.0 this kind of current, all right? Because this we did in the lab, so it's not as powerful as under the sun, all right? So you need to remember for each module, they will give you the current about 60 millivolts, 60 milliamps, while they give you about 15 volts. And since there are two modules connected, series connected together, then they give you around 30 volts, right? Now, let's go to, it's very good. Every group deserves. Okay, now this is parallel. Parallel you see, now voltage is 15, but current now 2 times the 60 milliamps. Now, but if you shaded one of the module, then current go half, and voltage did not drop that significant. So in parallel, when the solar cell is in parallel connection, it's hardly any problem. Doesn't cause any problem because you only, if you shade 1 second of the total area, then definitely you should have a current drop. But that will not cause extra problems, right? You still give you the output. And for group 3, again, since it's series connected, so again, voltage is high, current is low, then hardly any current. But if you are really serious about it, you see the current is a little bit higher than the previous one, right? What caused the difference?
The shaded room.
Shaded area, right? Actually, I was expecting this should be 0 as well because all the solar cells in one panel are series connected. So even though you cover only portions of the module, you're still able to get 0. But why it give you something instead of 0? Yes?
I think we could have reflection from that.
Yes, because some light just sneak in. So you are not fully covered.
Yeah.
So the sneak in just penetrating, so you get that. Good, very good. Okay, now this is the fourth group doing the measurement. Okay, actually, there's a little bit strain, right? So they measured again. They wait until everybody leaves, then measured again. So they get quite good result. This is the fourth one. They measure a second time, so that makes sense, right? Parallel. So you do have a sacrifice because has been covered. Some portion has been covered, but you still have a curve and about the same voltage that you have. Makes sense. And group 5. Group 5 is series connected, but it's only cover even smaller area. Okay. So again, we have 30 volts, and we have low current. And when we are partially shaded, then we should have current to 0, right? I was expecting, but it's not. And it's even higher than if we cover 1 second. So again, the light sneaking in may still be the result that causing some current generating here. Okay, very good. So give yourself applause. Okay. I try to plot this data using color to differentiate these 3. The first one is polysilicon, which is blue one. Okay, I use blue. And CIGS, I use red. And amorphous silicon, I use gray. Okay, so which one got the highest current if that is directly illuminated? CIGS, okay? And CIGS, then followed by polysilicon, followed by amorphous silicon. Okay. Now let's go to here. We are using red, green, blue. No, instead of compare between red, green, blue, we are considering observing which cell gives us highest efficiency. Amorphous or no, polysilicon, this is a little bit. We need to average 3 amorphous. Amorphous give us highest efficiency. You agree?
Yeah.
Okay. Now, amorphous, then which one? Poly. Amorphous poly, then CIGS. Amorphous poly, then CIGS. And how about here? Poly. CIGS. CIGS, poly, amorphous. Is that just opposite trend?
Yeah.
How come? How come? Yes, the source of light is different. So I'm trying to figure out by myself. So I draw a picture. I draw a view graph slide for you. Okay, so you have to find out the band gap of those 3 kinds of semiconductors. Amorphous silicon is actually not silicon. They're starting up with silicon wafer. That's true. But they are processing it in hydrogen or silane. So they make hydrogen bond. Not really hydrogen, no. They really do the chemical bonding. It's not hydrogen bond. Hydrogen bond is another meaning. They are doing bond, SiH bonding. So they become hydrate. It's hydride, sorry. They are hydride, actually silicon hydride. It's not pure silicon anymore. So this material is very different from the silicon, even though you may not be able to tell the difference, but actually the material is different. The band gap is much more than crystalline silicon, 1.6 and 1.1. So this has very big band gap. And the CIGS and polysilicon has around the same band gap. Okay, with CIGS has lower band gap. Where can I get this one? This data you can Google that, and actually and you can measure. You take one piece of the material and you measure the UV visible like slewing the wavelengths and see the absorption coefficient when it starts to absorb light. Then you will be able to determine the band gap. Do you remember yesterday I told you that there will be significant difference of the absorption coefficient when it is around, when the incident light wavelength is according to the band gap of the semiconductor. So there are a lot of ways to know that, and it's not very difficult. And the easy way is to find the literatures, and you can find that from Google nowadays. It's very easy now to study, to learn something nowadays. You don't even need to go to the library. Okay, so if we are using single wavelength light sources, what do you think which one will give you the high efficiency? Make sure you know all these 3 sources has same power output, has same output. So that means this one and this one has same output. Even though each photon, the green, for example, each green photon has higher energy than red one, that of red one. But red one will have more photons in number compared with blue light. That's why it will give us the same output.
But the speed,
Huh?
speed of
Speed is the same. Speed of light. Like the same. Okay? So it's a flux. You need to consider flux for per area, per unit time. How many particles or photons will impinge on the surface, right? So you know, if you are using single wavelength photon sources, then you should have band gap as closer as to the photon energy as possible. A little bit lower, but as closer as possible. Because energy higher above the valence conduction band will become thermal energy and wasted. So in this case, amorphous silicon will absorb most of the energies more efficiently, most efficient among these three, then followed by polysilicon, followed by CIGS. So this will be the trend when we are using this monochromatic light, the single energy light. When we're using this, then high band gap will give us the best result, as long as the band gap is still smaller than the photon energy of the incident light. Did anybody still don't understand what I just talked about? Please raise your hand. So you all understand? Okay, raise your hand if you understand what I'm talking about. Okay, thank you. Then I feel more comfortable. Thank you. Now, but that is not the case for the first experiment that we did. All right. For first experiment, do you remember what is incident light? White. White. So white is not monochromatic light anymore. They are bands. They are bands of continuous band. Almost, you can regard it as a continuous band of light. So the smaller the band gap, actually it will absorb any photon that is higher than the band gap. All right? So smaller semiconductor with smaller band gap will absorb more photon energies, even though portion of that will be dissipated through the thermalization process. But if the extra amount of light energy that can be absorbed by the semiconductor compensated for the losses by thermalization, then it might get higher energy. That's exactly what happens, and I believe so. And believe what you have seen is this effect. All right? So in this sense, the efficiency will have different trend than the previous monochromatic case. So CIGS becomes the highest provided, highest power output, followed by polysilicon, followed by amorphous silicon. All right? Okay. Okay, I pretty much did this before. Yes. So, if you are aware, if you are curious about how to find the band gap of the material, it's everywhere. Just Google it. It come out. More than that, you can absorb a lot. I mean, you can compare because different group has a different result, and you just need to collect whatever you think. Most people agree, then it might be correct. But be careful because the information in Google is not always correct. So you need to use your discretion. All right? Okay, very good. I think we have very successful lab works. So we'll continue the lab work. So I was planning to assemble dye-sensitized solar cell for everyone, but I need to count how many students are here. Let me count. Okay, maybe almost 50. Wow. So actually, when we were back in Taiwan, we were informed that you might have only 30 students. So since now we have 45 or 46 students here, we might not be able to afford to have enough number of solar cells that you can do. So I am planning to have, could you please form groups, two, we have one solar cell set for two, all right? So you can still participate. Now, there's another concern. Another concern is we need to use some chemicals, vinegars. Well, it's not, all the stuff are not poisonous, including titanium oxide. Titanium oxide usually we are using, is a major ingredient in suntan lotion, all right? And it's sometimes can be used as food additives. So it's not poisonous. And we are using vinegars, we are using alcohols. Just make sure you don't drink that, there'll be no problem. And that is because it's a healthy concern, because it might contain, it's industrial use to reduce germs. So it may contain some methanol. And methanol might be a little poisonous. If you don't drink, then it's no problem. If you just use as a medical purpose, then it's okay. That is for hygiene purpose. And we are using juice for the dye. We buy some vegetable with very dark color leaves. That's edible plants. We just buy from the supermarket. So we need to grind them and squeeze them juices, and we use that juice as dye to absorb the visible light. All right, and we are using iodine, the medicine that say if we hurt there with medicine iodine to clean your skin. Yes. So that one, we use that one as electrolyte, all right? So, and also we use candle to make graphite. We use candle to we use our glass to put on the flame, so they will be deposited with graphite. Yeah. And using this counter electrode. So everything is not harmful. However, it cannot be used in the electronics lab. Okay, there are some concerns. So I'm a little worried about how we conduct this one. So yesterday I was thinking about I will probably train, we still divide into 5 groups, but we are going to execute the lab together. But how? So I want to train 5 TA. Actually, I did already, but I'm not sure if they really remember the procedure. So in case they still didn't remember that well, I will always remind them during today's lecture. All right? So we will send 1 TA per group. You ask the TA if you have any question. Then if TA has concern or he's not sure about the procedure, then he will go to me, ask me for help, all right? All right. And there's one step, also a problem, that is titanium oxide electrode production. It takes time because after we scribe them on the electrode. They are wet. They are not fixed. You can wipe out by yourself, but we don't want. We want it to make bonding, chemical bonding, with transparent conducting oxide electrode. So we need to put this into the oven and heat it for at least half hour. All right? So this will be the most difficult part. Not difficult by process, it just takes time. So I think teaching assistant will teach you how to prepare the titanium oxide. Then after everybody finishes this step, I will collect the titanium oxide electrode from you and put it on the plate and put it into the oven together. And for at least 30 minutes. And during this 30 minutes, we'll do the squeezing of the leaves. So we have a dye coming out from the plants. This is what I expected. Now, but I'm not sure if we can finish that because we have only 2 hours. Is that okay? So later on, after we bake out the titanium oxide, it's on voluntary basis. If you are staying, we are staying with you to finish the procedure, all right? But if you think, okay, I know already, I know everything already, then you can leave, all right? Okay. So, and you know, the problem is we are not allowed. There will be a concern that we do this in the electronic lab. So we probably need to do this at the whole way. So it's kind of difficult, right? Yeah. It's kind of difficult. We still need to. Okay, so I'm not sure if Dr. Muhammad El-Badi.
Yeah, I think that.
Can we? But did anyone inform the chemistry lab? Okay, so we make, but can you make a phone call now or just go? Okay, please. Thank you very much and see. Okay, but how far is that chemical lab? I see. Okay, please tell me to that. Yes. Thank you very much. Okay, so we might solve the problem then. Not yet. We have something. Before we start the experiment, I need to tell you something about desensitized solar cell. Desensitized solar is different technology than I just talked about for the last 3 days. So you need to carefully aware of. Okay, so I will not go through every slides, but I will give you the slides anyway. You are supposed to receive this by today, but you might not have not received that. No problem. I already sent to Dr. El-Badi, so ask for him. If you want these handouts, just ask for him. Okay, I'll skip that. Now, let me tell you the structure of desensitized solar cell. And you may help me inform the one that helping me contact chemical department, all right? We start with ITO. Actually, we start with the top. So we do the top all the way to the bottom. We start with ITO. The ITO look like glass, transparent, but it's conducting. This material is very important, as I told you earlier. It's conducting while it's transparent. So it can be used in solar cell panels as well as TV screens and LED light sources. Okay, so we want the light to come through the ITO and into the titanium oxide and the dye. Dye means something with color. Something with color other than white means it will absorb light. Okay, if something is white, that means it scatters all the incident light, so it becomes white. Okay, so if it shows some color other than white, that means it will absorb some portions of the light in the visible spectrum. Okay, so we want dye to do this work for us. Yes?
Black color is the best. Oh.
Black color will be the best. It will absorb everything, any energy in the visible spectrum. Okay, so how to stabilize this dye? Dye is molecules. So if we can attach as many as possible dye, then dye will generate, once it absorbs light, it will generate electricity, right? Generate electron holes, right? So we want to have a porous titanium oxide so that we create the high surface area for dye to be absorbed into. Okay? So we should make a porous titanium oxide. However, porous titanium oxide, since it's porous, so the dye may penetrate through and direct connect to the ITO, which becomes short-circuited. We want this electron that excited on the dye molecule may pass through the conduction band of titanium oxide instead of go directly into ITO. So we should have very thin layer of barrier, dense titanium oxide to serve this function. However, we don't really do the barrier titanium. Since we are preparing titanium oxide, there will be portions of liquid going down, then automatically form a dense barrier titanium oxide. So we really don't do this step before this one. We are doing just a deposition of a porous titanium oxide at the same, in one step. Okay? Then after we finish, then we need to bake that. Otherwise, the titanium oxide will be wiped out if you are not careful. So we need to sinter. We are so-called sinter. Sinter means we form chemical bond between particles of titanium oxide. So they will form chemical compound and stabilize themselves while remaining, there's pores remaining in the structure. Now, after we absorb dye, we will, instead of putting electrolyte solution, we will put the counter electrode together. We'll clamp these two together, like using tapes to wrap them together. So wrap them together, and then there's still a crevice, very thin crevice. You can hardly see, but there are always crevices. So at this time, you dip the iodine solution. They will sneak through. They will penetrate through. Then that is done. Then you can take this one. You see, this is negative electrode and this positive. Then if you illuminate it, then it will generate electricity. All right? So this was something like this. Titanium oxide, these are titanium oxide particle, titanium oxide barrier, and this is dye. And this is a counter electrode. And if we tape them together and inject the electrolyte, then we will have the solar cell. For commercial solar cell, we use platinum as counter electrode. That is to deposit platinum on the glass. But since we are doing experiment and platinum is very expensive, so we are using candle to deposit graphite on top of the glasses. So it will still work, at least for demonstration purpose. You'll still get the efficiency, all right? Okay, so this will be the band diagram of the structure. So from left to right is ITO, transparent conducting side. Sometimes we using fluorine doped titanium, fluorine doped tin oxide. This is Indian doped tin oxide. Fluorine doped tin oxide will serve the same thing. They are all transparent conducting oxide. The next one layer will be titanium oxide that you are going to prepare and run most of the time, maybe half hour or more than half hour because of bake under the oven. All right? So after you finish preparing titanium oxide, or during the time when we are baking the titanium oxide, we will try to squeeze the leaves, to squeeze some juice out of the leaves to give us dye molecules. Then we can dip the solution of dye on the later on the titanium oxide, and it will absorb the dye into the porous structure of titanium oxide. All right? Then instead of inject electrolyte immediately after the dye dipping, we are going to clamp the counter electrode with the titanium oxide electrode together by using the tape. Just wrap it up. Maybe it's just one round. Because we don't want it too many rounds, because we still need to have transparency of the light. Right? Then after we wrap it up, then we dip some iodine solution in between. They will sink in. And now that's when your solar cell assembly is accomplished. Then you can test your work to see if that will work. If that will give you some voltage change under illumination. And you can compare with the voltage when that is without illumination, right? Okay. That's about it. Okay, so I probably will skip the rest of the content because of time limitation. But I think I just mentioned about the most important part of the solar cell. Dye-sensitized solar cell. It's not PN junction anymore. It's a new technology. You might be able to think why we need to use different technology, because this one you can tell if you are successful about assembling your dye-sensitized solar cell. It can be illuminated and still functioning under very dim light. Under that condition, usually conventional silicon solar cell is not functioning. So it has different market approach. It has different function other than silicon-based solar cell. So this dye-sensitized solar cell is usually predicted that it can be used indoors. Especially nowadays, you have iPhones, you have cellular phones to charge always, right? Instead of plugging into the wall plug outlet, you can always use solar modules. But instead of using silicon-based solar module, because it's not functioning under this light, you can use this one, all right? Efficiency. Solar cell, for this kind, the highest one is like 11 or 12. But again, this has very special property, characteristic. For example, it's less sensitive to the angle because since we have this porous structure, as long as light is coming in, it will scatter and let the dye to absorb the light. So it will not like a flat surface of a silicon solar panel. So it is less sensitive to the angle of incident light. And also, since that, so if you put outside from the sunrise to sunset, they are always angle, right? different angles. So turnout efficiency generated by desensitized solar cell per day is higher than the silicon solar cell. All right? Because we cannot always focus on tracking the sun. So turnout, this efficiency is higher. Okay, so I just want to mention just one among some of the characteristics of desensitized solar cell. But you can figure out later. Once you have an experiment on doing this, then you have the feeling about this kind of solar cell, then you can find the properties by yourself, all right, in the future. Okay, so I think it's about time to move to the lab, but I'm not sure if someone help me. Yes? So we are? Come to us. We can go now? Thank you very much. Thank you very much for your help. Okay, so do you know where chemistry lab is? Okay, so can you lead us to there? Now, thank you very much. But you have to wait for me then, because I need to. Have you finished checking the conductivity? I'll show you next how to wipe the titanium oxide on the glasses. Just one piece, please. Let's do one piece first. Then you will repeat the rest by yourself. Yes. Have you done that yet? We are not going to do really solar cell. Just want to sure of the conducting side. Just need to full coverage of the exposed area, so you will not see the bottom layer, the conducting side layer anymore. And keep it flat.
هو يبغى طبقة بسيطة ما يبغى وايد على المقطع ما أعرف صراحة.
تويش تخصك.
أيوة كامل.
في واحد من اختار هو
زيدي شوي.
Let me take a look.
بعده إنها قسم صور. هذا بعدين لكن بس تسكوها وتنظفوا السايت.
أيوة.
تيشوز. هذيك كانت زينة.
Just a second, we haven't gone to that step yet. Just a second, I need to tell you because you need 1, 2, 3, 4. You want to close one, okay? Yes.
Don't mix with us.
هاي أول تجربة.
Okay.
This is the first try.
Oh, this is first try. Okay.
So in case
In case,
performance.
yeah, okay.
Okay, all finished?
Okay. Now we have all finished the titanium.
So during the half hour, you
I will ask them to do something else, like
okay.
squeeze the juice. Or rather than use the
غاية
blender.
فيها السالفة
I'm afraid they will drink it.
Oh, then you try to prevent them from drinking this stuff, right? So we are setting at the maximum 250 degree and 4 strength heating, and we heat it for more than 30 minutes. So how about let's set at 40, and we can take that after 30 minutes at least. This is something like a cooking program, right?
But it's still white.
Huh?
Look like a yellow.
Yellow, no problem. A little